do some very brief notes in Chapter 13. As I was saying, there's a few things that I want to make sure that you guys have been exposed to in case you see them on upcoming standardized tests like the ACT and the MME and that kind of thing. That's where they'll show up. Before we begin that part, just a little bit of review of mean, median, and mode to make sure that they're straight in your mind. They're all measures of averages of central tendency, but they measure different things, and then of course the range. So the mean is the one that's most commonly referred to as the average. That's where you add them all up and you divide by the total number that you have. Okay, it's the average. So the total divided by the number of items in the group. The median, where's the median on a highway? It's the middle number. And they have to be in numerical order. And then the mode is the most. M-O-M-O, both four-letter words, most. So which number occurs the most? And it could be a tie. If you had two that occurred the same amount of times, it would be bimodal. 3 would be trimodal. The range is the highest minus the lowest. So we'll be talking about that stuff as we get through this unit as well. So that's your little 13.6 review. For 13.7, we have some definitions. So we have a stem and leaf plot. It's a data display that organizes data based on their digits. You can pause if you need to. Frequency. The frequency of an interval, which is the range of numbers, an interval is range of numbers. So the frequency of an interval of data values that are in that interval. A frequency table is used to group data values into equal intervals with no gaps or overlapping intervals. And a histogram is a bar graph that displays data from a frequency table. And here's the key. It's a bar graph where the bars touch. In normal bar graphs, the bars don't touch, but they touch in a histogram. So we're going to first talk about a stem and leaf plot. It says a survey asked people how many miles they commute to work. The results are listed below. Make a stem and leaf plot of the data. And here's all the different data values. So the first thing we're going to do is we're going to make a stem, and that's going to be the tens digit in all of these numbers. If there isn't a tens digit, well, it would be as if there is a 0 there. So my smallest stem is going to be 0. My tallest stem, my biggest number here, is 35, I believe. So that's going to be my biggest stem. If there was nothing in the tens, for example, I would still put a 1 there. There just would be nothing there. All right, so what you're going to do is you're going to just go through, and I cross off as I'm putting the ones digit in. There are no commas in a stem and leaf plot. Sometimes people try to add them in. Oops, I almost put that in the wrong spot. Just adding the ones digit. You'll notice that 5 occurred twice, and I write 5 in there twice. Okay, so that was just getting them into the right stem. After that, you actually have to write the leaves in increasing order. Increasing order. So that's what I'm going to do right now. Okay? And then we need a key. What does 3/5 mean? It means 35 miles. So that would mean 10 miles, 23 miles, 5 miles, and so on. So you always have a key to explain what it means. So this right here is my finished product. This was just helping me organize it. Okay, so what you're going to do on the next page here is you are going to make your own stem and leaf plot from this data. And we'll say that this again is in, we'll say it's feet this time. We'll say the units are feet. Oops, on the screen. Okay, so pause. go ahead and work it all out and come back and see if you have it. All right, so this is what you should have had for your stem and leaf plot. The stem started at 3 because that was the smallest one. You don't need 0, 1, or 2 if there are none in that area. Goes up to 6, and they are in numerical order, and your key, you can pick any one you want. So you probably don't have 4/3. I just picked that. It means 4.3 feet, not 43 feet. So make sure that you have that in there correctly. There are no decimal points, as you can see in my leaves. All right, example 2, we're going to get 2 different sets of data. So we're going to do a back-to-back stem and leaf plot. So what we have here is we have the 9th grade and we have the 10th grade. We have a fundraiser sales in hundreds of dollars of the homerooms in 2 different grades, and we're going to compare the sales in each grade. So we have 5, 6, 7, and 8 as our stems, and this is in hundreds of dollars, remember. So a 7.3 in hundreds of dollars, what number would that be? That would be $7,300. So you have to think of it like that. This doesn't mean 37, this means 7.3. This one means 7.0, okay? All right, so it wants us to kind of basically just look at the data and what can we tell. So when I'm just glancing at this data here, who sold more, 9th graders or 10th graders? Well, look at how many are right here in the 8s, right? Most of these are in the 7s, so you can just glance at a stem and leaf plot and be able to tell things like that. So 9th grade definitely sold more. So it says consider the distribution of the data. The interval for 7.0 and 7.9 hundreds of dollars in sales contains more than half of the 10th grade homerooms. While the interval of 8 to 8.9 hundreds of dollars in sales is more than half in 9th grade. So what we can say is the clustering of the data shows that the 9th grade fundraiser were generally higher than the 10th grade fundraiser. So the point of a stem and leaf plot is just to be able to give it a quick glance and be able to make a determination easily, as opposed to having all those numbers listed all over the place. It would be a lot harder to determine which one sold more. All right, example 3, we're going to make a histogram, and we're actually going to make a frequency table as well. So we have birth weight. The birth weight in ounces of babies born at a hospital are listed below. Make a histogram of that data. So here is the birth weight in ounces, and we're going to make a frequency table first. So this is a frequency table. Okay, and what we have to do is we have to choose intervals that are equal in size, and this is the key concept, equal. They have to be equal. So what I have to do to identify that is I have to find my low and my high. My low is 96, and my high is 136, it looks like. So I know that I need to go from the 90s to the upper 130s, basically. If I start at 90, I don't have one that's 90, but I have to have equal intervals. So I'm going to go 90 to 99, 100 to 109. There are 10 numbers in each one, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 is 10. There are 10 numbers. I go all the way to 139, even though there wasn't one that went all the way up there, because I have to have my intervals be equal. Once you've done that, you're going to make a tally mark next to that in that column. So 96 would be in the 90s, 128, 115, 120, 107, 125, 136. Finishing this up. Okay, so a lot of times there'll be a total column. I'm going to add a total column here, and we would have 1, 1, 3, 4, 2 in my total column. So that's a frequency table. And then a histogram we use to organize the data. The bars are touching, remember. So I have to have 5 bars, 1, 2, 3, 4, and that'll be my 5th You should use a ruler really, or just taking notes so we're eyeballing it out. So my first one is 1, and that was my 90 to 99. You can use different colors if you'd like as well. 100 to 109 was also 1. 100 to 109. 110 to 119 was 3. 120 to 129 was 4. That was my highest frequency. And then 130 to 139 was 2. Okay, notice my bars are touching. There's my histogram. I have my labels on my axes as well. So you could glance at that and say, hey, on average, babies are kind of born in this range. This is kind of low birth weight here. Okay, so we have one down here. You're going to make a histogram of this data down here. You're going to pause the video. What do you have to make first? A frequency table, right? And then you're going to make your histogram. So go ahead and do that, and then come back and see how you did. Okay, so here we go. So I noticed that my low was just over 18. My high was in the 20s, 2089. So I started from 18 and went up to essentially 21. So 18.00 to 18.99. I have the same interval each time. They're basically 1, right? Counting by 1. So I had 3, 2, and 4. You want your intervals to be somewhere between 3 and 5. That's really a good thing for a histogram. They didn't give me any data here as far as what we were talking about, so I just wrote intervals and frequency as my labels, and there's my ranges down there. All right? So go ahead and talk to Ms. Wyman if you have a question about any of that. Otherwise, you can proceed to the next set of notes and practice.